Welcome to Spotlight ETSU. I'm your host, Carrie Oliveira. Today we'll be speaking with Dr. Blaine Schubert, director of the Natural History Museum. Dr. Schubert specializes in cave paleontology and has led cave trips in southern Appalachia and the Ozarks. He also serves as the director of the paleontology program at ETSU, which focuses on finding and conserving fossil remains from Appalachian caves. Dr. Schubert is also an associate professor in the Department of Geosciences. Thank you so much for joining us, Dr.
Thanks
Schubert.
for having me.
I've never talked to a paleontologist before, so I'm going to get to that here momentarily.
Okay.
But tell us how it is that you got to ETSU. How long have you been here?
Okay, well, I have actually been here since 2004.
Okay.
I came as a postdoc because of the Gray Fossil Site. Steve Wallace, who used to be the director, he's now one of our curators, he actually sent me a picture of some of the material from the Gray Fossil Site.
And you got super excited.
And I got really excited. I had already known about the site a little bit before that, but he recruited me in 2004.
And so you've been here a good little while then.
So I was a postdoc for 2 years, then I became a faculty member in 2006.
And here you are playing in the fossil site. That's so exciting. And running the Natural History Museum, which is awesome.
And I've only been doing that for a year.
Only a year, so that's a kind of a new gig for you.
It is.
So prior to that, you were just in geosciences.
That's right.
Okay, so you're a paleontologist. What exactly is a paleontologist? Not a dinosaur expert like most people think.
So, some paleontologists are dinosaur experts.
Right.
What people typically get confused on is what is the difference between a paleontologist and an archaeologist.
That was what I was going to ask you.
Okay.
Okay.
So the difference between a paleontologist and an archaeologist. Paleontologists study fossils. They study remains of past life.
So you're like forensic anthropologists, but for non-human species.
Yes.
Okay.
Exactly. Although there is a gray line sometimes, so I could be a paleontologist that works on 5 million year old hominids.
Pre-humans.
Pre-humans.
Right.
And then I would be sort of a mixture of an anthropologist and a paleontologist.
Okay.
But an archaeologist studies basically human culture through time by looking at artifacts.
Okay.
Okay, so that's really the difference. Fossils versus artifacts.
So you're digging around sort of in the same places sometimes, or in the fossil record or wherever,
in the dirt.
Caves.
In the dirt,
In the dirt mostly, so it's a dirty job.
Yes.
Somebody's got to do it. And then you get bears and things. We're going to talk about the bears here momentarily. So how is it that you decided that you wanted to study, how do you grow up thinking you're going to be a paleontologist? When did you figure that one out?
It seems to me that actually a lot of people grow up thinking they want to be a paleontologist.
They just don't know it, or?
Well, I meet a lot of kids that say they
Yes.
want to be paleontologists, but not everybody knows what a paleontologist is, and most people that have heard the word paleontologist think dinosaurs.
Yes.
And they think exclusively dinosaurs. And what we can talk about is how most fossils are not dinosaurs.
No, they're
They're
not.
just one group of fossil animals. And in fact, we don't have any dinosaurs from our fossil site at our museum.
And you have a dinosaur telling people this as they walk into the
When most
fossil
people
site.
when most people come to a natural history museum, it is to see dinosaurs.
Right.
And it's sort of fossil equals dinosaurs is the mentality of most people. Fossil equals dinosaur.
Yes.
But what we want to teach when people walk in is what is a dinosaur and why don't we have them at the Gray Fossil Site?
Why don't we have dinosaurs at the Gray Fossil Site?
Well, there are a couple of reasons. The Gray Fossil Site is about 5 million years old. We date it to between 4.5 and 7 million, which is a long time ago, no question.
Quite,
right?
yes.
But geologists typically throw around these millions of years like nothing.
Right, like they mean something to ordinary people, really, is part of what the problem is. You know what I mean? Like
Right.
4 million years, I have no frame of reference for 4 million anything.
Yeah,
Never
but
mind
that's
years.
just, it's just a little fraction of time.
Right.
And dinosaurs actually go extinct in the fossil record about 65 million years ago.
Well.
So that's quite a gap between, 5 million. They've been extinct for 60 million years by the time we get to the
fossil
Gray
site ever
Fossil
existed.
Site. But if we actually preserved rock in this area from 65 million years ago, which we don't,
Right.
it would have been a different kind of environment. It would have, if we look at Tennessee during that time, Tennessee would have already had its Appalachian Mountains. Okay. And they are in a state of weathering and erosion because they're high areas. Where do we find fossils? We find fossils in areas that are low and sediments are accumulating. So this area would have been an area of weathering and erosion, and those rocks are gone. The rocks from that time period that are up here are gone, and actually the rocks that are under us are hundreds of millions of years older. So they're actually...
So there's like a gap in the rock record
here. There's a gap in the rock record here. So the limestone that's underneath us is much older than the age of dinosaurs.
And everything on top is much younger.
Is much, much younger. But if we go in the caves, we can find things that are millions of years old, things that are thousands of years old because sediments have accumulated in those caves over time.
How did you decide you wanted to study caves specifically? Was there something you were looking for in caves?
Well, you asked me how I got interested in paleontology, and it was that I grew up in the Ozarks of Missouri, which is very much like Tennessee in that it's full of caves. It's full of limestone that is hundreds of millions of years old. And that limestone has pockets of caves running throughout it. It's like Swiss cheese underneath us. And in those caves, you get all kinds of Ice Age animals, animals that date to between 10,000 and 100,000 years old.
The cartoon just ran through my head. I'm seeing woolly mammoths and sloths or whatever those animals were. And saber-tooth, we're going to talk about this. Cats.
Yes.
Not tigers.
Right.
So caves are a good place for the record to be preserved.
Are a really good place for the record to be preserved. And I started going into caves when I was a kid. And then as I grew up into college, I started realizing that a lot of these caves preserve Ice Age fossils. So I started combining these interests and looking in caves for these fossils. And that's what led me on my career to being a paleontologist. Now I do a lot more than cave paleontology. I do work in a lot of other areas too, but I always like to go back to the caves.
Oh, caves are cool. I've never been in a cave. I don't think.
I'm thinking of which one we could take you to.
Bats is what I worry about.
Why?
Well, I'm from Hawaii. We don't have bats.
Okay.
And the idea of a flying rodent freaks me out.
It's not a rodent.
So a saber-tooth tiger is not a tiger, and a bat is not a rodent, and apparently a pterodactyl is not a dinosaur?
Nope.
You want to tell me about that one, please?
So,
and then you're going to tell me about this bear right here.
Okay, so what we have is, what was the question?
Why is a pterodactyl not a dinosaur?
Okay, so pterodactyls are a type of reptile, like dinosaurs are.
I was going to say, I'm pretty sure dinosaurs are reptiles.
Dinosaurs are reptiles, anyway. But they're different groups. They're totally different groups. And so the first flying animals on land that were vertebrates, were the pterosaurs and pterodactyl group. They are different from dinosaurs in that if you look at the bone structure, if you look at the detailed anatomy, they are not a dinosaur. Just like we define...
So they're not lizards, they're birds.
No,
they're reptiles.
Yeah, so they're reptiles. But they, just like a lizard is not a dinosaur.
Oh, my Lord.
A pterosaur or a pterodactyl
is
not a dinosaur.
What does that terra mean? Doesn't it mean... What does that mean? So you talk pterosaurs and pterodactyls. What does that terra prefix mean?
I wish I knew. I can't think of what pterodactyl means. You got me.
Yes! I stumped the paleontologist. I'm so excited about that. So the point is that a pterodactyl is not in fact a dinosaur, but it's a flying reptilian vertebrate. But all reptiles are vertebrates.
Yes.
Okay, I got that much. God, yes, 8th grade science is coming back to me. Okay. You also told me that saber-tooth tiger is not a tiger.
That's right.
Because it's different than what we consider modern tigers. It's a different sort of branch of thing.
Yeah, in science, in paleontology, in biology, we try and avoid the common names because oftentimes they're really confuse what we're talking about.
Sure.
And so when we use the word tiger, everybody gets an image in their head of the striped animal that we have today.
Correct.
So the saber-toothed cat group, I call it cat because they're not related to the tigers of today. They're a totally different group, or ocelots or pumas. They're not related to that group. There were actually multiple episodes of the development of saber teeth in extinct types of cats and cat-like animals. In fact, there was a marsupial animal that lived in South America that had saber teeth. So it co-evolved the same type of tooth structure for the same type of purpose,
I'm
but
imagining
in
a kangaroo
totally
with
different group.
saber
Yeah,
teeth.
so you're talking about an animal that's more closely related to a possum that we have out here on our streets today
Those poor
than
hideous
to
animals.
cats.
Oh!
And to cats.
No.
Yeah.
Oh.
But
How do you know any of this? This is what I have always found fascinating about people who study fossils. Like, okay, can we see the alligator here for a second?
So
this is allegedly an alligator.
Yeah, allegedly.
You know
Not
that this
allegedly.
is an alligator.
Yeah.
You know for sure 100% that this is an alligator. To me, it looks like a tree log. So two things that I find interesting about people who study fossils and the fossil record are, one, how do you come to be able to see that this is what you're sure it is? I'm sure it's a log. You know it's an animal.
Right.
How do you learn for that to be the case? And the other question I have is, how can we... I'm going to ask you that question later. Tell me about how you know that's an alligator.
Okay, so what we do as anatomists, as paleontologists, is we spend a lot of time studying the detailed structure of the animals that we work on. And so in this case, this is an alligator. You can see the eyes right here.
Yes.
The nose is coming out here. It's actually broken off right here. This is the lower jaw, still attached.
Right.
and here are the teeth.
He does have teeth.
Okay.
That's pretty obvious he does have teeth.
If you were to compare it to...
This is an eye socket right here?
Nope, no. This is an eye.
That's an eye.
And this is an eye. And this side of the face is broken off,
Gotcha.
and he's a little bit distorted.
Oh.
This would be where the vertebrae come out, and the animal would go in this direction towards the tail.
How big would he have been? This
animal would have been about 6 to 7 feet long.
I don't want to tangle with that guy.
So how we know is we spend a lot of time studying the anatomy of modern animals.
Yes.
And in geosciences, we have over 13,000 skeletons of different kinds of animals. We have casts of animals as well, and we have classes that teach about all of these anatomical details. So there is tons of information all over this skull that tell me it's a vertebrate, it's an archosaur, it's a crocodilian, it's an alligator, and what species of alligator is. In fact, it's a new type of alligator. It's a new species of alligator that we're working on from the Gray fossil site.
This guy came from the Gray fossil site?
Yeah, so this one's from Gray. And what we have at Gray is a lot of specimens of alligators. And it's pretty cool to think about.
Why so many alligators? Because it's not very swampy here.
Well, it was. So it was warmer. One of the things that this alligator told us is it was warmer here because alligators don't like it when it freezes.
No, I don't like it when it freezes.
So it was warmer here at that time.
Okay.
It was actually warmer and more subtropical. Some of the other animals tell us that as well.
How does something like that happen? How do we have like a massive climate shift in an area?
Yeah.
Is it tectonic plates or is it just the weather has changed, like global warming?
All of the above.
All of that?
All of the above. Plate tectonics. Exactly.
I'm like 5 million too late, 5 million years too late for the weather in Tennessee.
Well, we would have actually had alligators all the way up into places like Nebraska in the past. There are alligators, fossils found way up into Canada, at times even farther back. And so it tells us about climate change, and that climate change is something that's always happening.
Right.
And paleontologists are actually one of the big informants on how climate change impacts organisms.
Oh.
Okay, so if we can say, how is climate changing, then we can look at the animals themselves. How are they adapting or maybe even going extinct? Right, over time. So there's a lot that we do that can inform modern conservation.
Well, one of the things I was going to ask about is, okay, so it's kind of fun to like look at the fossil record and see what kind of weird animals are just for the sake of like knowledge, but is there a practical utility for understanding something that existed 5 million years ago? So current animal conservation then is one of the consequences of you studying the alligator that clearly no longer exists.
That's completely right. And the more recent that we work on specimens, so if I work on something that's 5,000 years old or something that's 10,000 years old, that could actually inform us a lot about the animals that are even still alive today, can't it? Because they're not extinct yet.
Yes.
And so the farther we go back in time, probably the less it can inform us about our modern ecosystems.
Right.
So that's one of the reasons we're really interested in cave faunas, because those are anywhere from 500 years old to 20,000 years old. So faunas are animals, floras are plants.
Okay.
Yeah.
Yes, I was going to ask about
There are also names on the Addams family, I think.
On the Addams family?
Fauna and flora.
Are they?
Yeah.
Are they like fairies or something? I don't know. It's been a long time since I've seen the Addams family. We have a bear.
Yep.
Well, we have 2 bears. Let's talk about the little bear.
Well, what this is a modern black bear.
Okay.
So it's an example of one of the specimens in our comparative collection that we use. And we get bears from all over the place.
Right.
Typically bears that get hit by vehicles, unfortunately. But we do...
Do cars survive hitting bears?
Not very well.
No, I would imagine
not. Very well. But so what we're looking at is the top of the skull. So the lower jaw would go here, and then we turn it over and we're looking at the teeth. And this is really informative to me. It tells me the kind of diet.
You can tell what the bear ate just by looking at his teeth?
Looking at the shape of teeth can tell us what an animal eats.
What does he eat?
So he's an omnivore. He's like us.
So he eats Big Macs.
Eats whatever he can.
Doesn't eat salad,
whatever he can get a hold of. These are the canines, which we were talking about saber-toothed cats. This is the tooth that gets really long in those saber-toothed cats. But all of the detail of the skull is informative to me and tells me something about this animal in the past. We have bears at the Gray fossil site too.
Right.
And they were even a little bit smaller than this animal right here.
Right.
Close to the same size, but a little bit smaller. And it would actually, the bear that we get from the Gray fossil site would be an ancestor to this guy here.
This guy, who I've named Barnabas, though no one is feeling that. I'm going to pick him up.
Yeah, so there's a particular group of bears that are called short-faced bears.
Short-faced bears.
Short-faced bears. So if you hold it to the side.
A bear doesn't have a particularly long face anyway.
Well, compare the size of this skull, but the fact that his nose is a little bit longer. And some living bears would actually have snouts that are even longer than this. But these bears, for their skull size, had a short snout, and they also had relatively long legs.
And kind of small teeth, well, short teeth.
Short teeth, yes, but relatively large in diameter.
Yes.
So big and large for crushing. And if you turn the snout and let the camera see the snout you can see how large that nasal opening is. And a large nasal opening means really high sensitivity to smell. So you're talking about an animal that would be able to smell a carcass of a mammoth or a mastodon from miles away, and then be able to go towards that and dominate it and scare anything else away from it.
You were telling me how big this bear, what kind of bear is this?
So this is the giant short-faced bear.
A giant short-faced bear.
We didn't have these from the gray fossil site that were this large. We have a smaller version of it that's much older. This bear species lived at the end of the Ice Age.
Okay.
So it went extinct around 12,000 years ago, basically. But people did overlap with it here in North America. And this bear would be about 5 feet at the shoulder when on all fours.
That's like me. That's the height of like a woman.
Yeah.
At the shoulders, which means his head would have been considerably, well, I mean, look at this giant head.
You'd be looking at eye to eye, yeah. Or he'd be looking down at you.
Would he attack me?
I would hope so. No.
Also!
No, not hope so. But I think the thing about these bears, one of the things that's exciting to me is that they did overlap with humans.
That is cool.
And what we haven't found is like a human that's been eaten by them yet.
How would you even know that?
Well, you would know if you found it in the stomach of one of them.
Okay, but you wouldn't find a stomach of a fossil.
You could. You could find it, so you wouldn't find the actual stomach.
Okay.
But you could find human bones within the stomach area.
Right.
And that's something that we do find sometimes. So we might find a skeleton of an animal that's been fossilized,
yes.
and then in the stomach cavity area find what they actually eat.
Yeah.
There's a whole other field where people that study fossil poop too. And you can study fossil poop, and we actually have one of the world's largest collections in the bottom of Ross Hall of,
we have
of fossil poo.
I just
both
want to repeat
fossil
that.
And modern.
I want to repeat that for our viewers. In Ross Hall, we have one of the world's
yes.
largest collections of both fossilized and modern poop.
That's right. You should come check it out.
That's the most interesting invitation I have ever had.
So imagine if we found some bear poo,
yeah,
right, fossilized bear poo, and then you had a human tooth in it. That'd be a pretty good indicator.
Totally ate people. I hope he didn't. That would be mean. So this is so fascinating, the amount of information you can get from just parts and pieces, because, okay, so at the Gray Fossil Site, how often do you find an intact skeleton?
Well, there are many extraordinary aspects of the Gray Fossil Site, and one of the extraordinary aspects is that a lot of the animals we recover are actually articulated, which means that the bones are still in the life position or the death position of the animal. So the animals are sinking down to the bottom of this lake, and they are still in that position of where they sunk down.
Oh, no.
The rhinos that we have excavated, for example, have been in that life position. We have more tapirs from our fossil site than any other site in the world.
I've never totally been clear on what a tapir is. Is it like a rhinoceros elephant thing?
It's a good guess, yeah. So it's more closely related to rhinos and horses than any other living animals.
Are horses and rhinos related to each other?
They're a group called the Perissodactyls, which have to do with the foot structure. Okay, have to do with the foot structure. It's known as the odd-toed group.
Okay.
So the odd number of toes. If you look at horses and what they have on the ground.
Do horses have toes?
Yeah.
What?
Yeah.
They have hooves, I thought.
Well, yeah, they have a hoof, but what has happened over time is that they have decreased the number of toes that they have, and they still have remnants of some of their toes up on the sides of their feet. Yeah. But their main toe that's on the ground is one of the middle toes. The other toes have been lost over time. And if you go far enough in the fossil record back, you'll find horses with 3 toes that are on the ground, for example. And then over time, they reduce that number. But anyway, rhinos, tapirs, horses are all within this group, and they're more closely related to each other than any of them are to what we call the artiodactyls, which are most of the other hooved animals that are even-toed animals. Peccaries, pigs, cows, sheep, all of those animals are more closely related to each other than any of them are to the horses, rhinos, and tapirs.
So you're telling me that a rhino is more closely related to a horse than a saber-toothed cat was related to a tiger?
Oh yeah. I can tell you that by looking at morphology,
Blowing
but you could
my
also
mind.
do genetics, and it would tell you the exact same thing.
Can you get DNA out of a fossil?
Sure. Sure.
And so does that allow us then to sort of differentiate species? Or like, so are there different species of tapirs, for example, and we're able to tell them apart not only because of their like physical bone structure, but because of their like genetic components as well?
Totally.
Oh my gosh!
Yeah, one of the great things about this whole genetic revolution is that it's verifying what we've done based on just visual observation.
Which has to be so great, because I imagine that there's a certain amount of error associated with making a visual inspection of something, right? I mean, if something, say if that alligator had a disease or whatever, might it cause it to look unlike the species that it actually is? And then having the DNA record would be like, oh no, he was just sick, or he got punched in the face or something.
That's why we try not to base too much on single fossils. We look at populations, bigger representations of fossil groups.
Which is why something like the Great Fossil Site, I imagine, is very cool, because you know what period of time it came from, you know that all those things, you have a collection of, okay, we have a bunch of tapirs here, and so we can compare them to each other and be able to draw better conclusions about what it is we're supposed to know from those things. Let's talk about the museum.
Okay.
I've been to the museum a couple of times, and you walk in and there's a standing exhibit that takes you through history, basically, and all kinds of, like, you see the dinosaurs on the wall, but we don't have any fossils. But you have the red pandas and the tapirs and whatever else that we found here. But my favorite thing is looking at the exhibits. You can go upstairs and you can see where the workroom where you guys all have the casts, you're making the casts of everything, which is part of what goes on in a museum is you're preserving these things, right? So it's not that the skulls are necessarily on display, but it's casts of skulls, right?
If it's behind glass, it's typically the real thing.
Okay. And the rest of the time, if you're going to let me touch it, it's a fake.
That's right.
Because I'm probably going to break it. That's pretty awful.
So yeah, I mean, the Natural History Museum it's a regional treasure, it's a national treasure.
It is a treasure.
It's an international destination too. It's so unique because of the fact that it's the only site like it in the world. If we look at the entire Appalachians, from Alabama all the way up to Maine and New York, there's no other fossil site from this time frame. What does that mean? It means that we're looking at an environment that's not preserved anywhere else in the fossil record for that time. So most of the animals that we find, and the plants, many of them, are entirely new to science.
Oh my gosh!
And so we're describing these new species as we find them.
Why is it that we're the only place that this particular period of time has been preserved in this area, or in Appalachia?
Well, it could be that there are more sites like this. We just haven't found them yet. It was found by a road construction project, so they had to dig pretty deep to actually hit the deposit.
Isn't that how they found the dinosaur Sue, the T-Rex? Was that by an accident? I mean, they couldn't have been looking for a T-Rex.
Most fossil sites are found by accident, but people were actually out looking for fossils when they found that.
Are road crews trained to, like,
No.
So they just do so how many fossil sites do you suppose we lose?
I think we probably lose a lot, because also if somebody hits bone and they know that it might slow down the construction process, they might not say anything about it. And we know that happens sometimes. So we were really fortunate that whoever it was that said, hey, we need to stop and look at this because we're hitting some big bone here.
Oh my gosh.
That's how the fossil site was actually saved.
That's exciting. And then you built a museum all up around it, and so
it's one of the only sites too where the fossil site and the museum are next to each other. Yeah, and so we can excavate our fossils, wheel them right into our preparation lab. People can watch us dig them up. They can watch us clean them and put them back together again.
Can I really watch you dig up the fossils?
Sure.
How do I do that?
Well, you come out and visit. We start digging next week.
We start digging next week.
Yeah.
And so I can walk into the museum and be like, hey, I want to watch this guys dig the bones up. And they'll be like, sure, no problem.
Yep, come on out. Yeah, come on out. I mean, we have a deck, an observation deck now that you can see the fossils being excavated. We have a new building, which is an education annex if you haven't been there in a while.
I don't think that I have.
And you can take a tour out onto the fossil site and watch us excavating. So we start excavating next week, and then on April 20th is our Earth Day event, which is a big celebration, and we're going to have excavations going on. We're going to have all kinds of activities for kids. We're going to have some professional paleontologists talking. We're going to talk about what are the relationships and links between paleontology and conservation and Earth Day. So what are those links, which we talked a little bit about before? So it's a big celebration. So I hope that
of Earthness.
Dirt
and whatnot. That's so cool. So right now there's an exhibit that's going on through the middle of May, I guess the third week of May, hatching the past dinosaur eggs and babies. So you have a temporary exhibit of dinosaur eggs. So sometimes you can see dinosaurs at the Great Fossil Site.
There's no question you can see dinosaurs at the fossil site, because we have right now a Triceratops in the lobby. Yeah, in the lobby, again, which explains the difference between why we don't have dinosaurs at our fossil site and where they did occur. But we have a temporary exhibit called Hatching the Past that is all about reproduction in dinosaurs and their eggs. And there are lots and lots of real eggs from dinosaurs in there and lots of great displays on how that worked.
I'm fascinated at the fact that an egg could get fossilized. I feel like they would be very fragile. I mean, they're designed not to be, right? I mean, their shape and whatever else are sort of designed to be protective, but at the same time you're talking about Earth piled on top of eggs. I imagine they would all just go splat. So it blows my mind that we have eggs intact. And do we learn anything different about a dinosaur or any species from studying the contents of its eggs than we do from studying its body?
Oh yeah. If you can actually study the development of young animals, it tells you a lot about the life history of that animal, because young animals go through a series of changes that tells us about what they're going to be like.
Right.
And if we can study growth patterns in dinosaurs, how fast do they grow, how closely related are they to birds, for example.
How closely are dinosaurs related to birds?
Birds are actually dinosaurs.
I know. I had a bird once. I was convinced it was a dinosaur.
Yeah, it is pretty exciting. It's not that birds came from all dinosaurs. It's that birds came from a very specific, narrow group of dinosaurs.
Right.
Okay, so they didn't come from
T-Rex.
They didn't come from T-Rex directly. They didn't come from Stegosaurus. They didn't come from Brontosaurus. They came from a group related to T-Rex. They came from a group related to the Velociraptor type group.
But they did not come from a group.
But they didn't come directly from them. Okay?
Well, they also didn't come from a group related to pterodactyls, apparently,
not at
because
all.
they were not dinosaurs.
Yeah, not at all.
I'm gonna have to mull all this information over. So birds, so like if I have a pet, I had a pet lovebird once.
Right.
So really, you're talking about millions and millions of years of evolutionary relationship to T-Rex?
Oh yeah, for sure. Yeah, so if you get, you go out to the store and you buy a chicken and you take all the bones and you clean those bones off and you lay those bones out, and then I showed you a cast of a dinosaur bone, and I showed you some other kinds of animal bones and said, which two are more closely related? You would pick up your chicken, and you would pick up the dinosaur and say, wow, wow.
Oh my God. I don't like the idea of eating a dinosaur, though, so that...
Well, you do if you like chicken.
I can't talk about eating dinosaurs. It's just too weird for me. So what else is going on at the museum?
So as I mentioned, we have the Earth Day event coming up. We have speaker series. We have some monthly lectures.
There was the Darwin.
So we had the Darwin Day, which was a big hit.
Big deal, right? And I was wanting to go, and I don't know why I didn't, but I was like, I follow the museum on Twitter, which is one of my favorite things ever. And you guys post from National Geographic. Recently, you guys posted something about how T-Rex was even more vicious than we thought he was. I didn't think that was possible. So that's cool. But yeah, you guys were tweeting about the Darwin exhibit, and you tend to tweet about things that are going on. So that's pretty cool.
So basically, advances in science, we're always talking about that. I also do excavations, I should mention, in Saltville, Virginia, which is about an hour and a half north of here. Have you ever been there?
I've not.
Okay.
Is there a reason I would have?
It's a cool little town.
Okay.
They have a little museum called the Museum of the Middle Appalachians. And it's sort of a mixture of the Civil War and fossils and artifacts, because that town played a major role in supplying salt during the Civil War. That's why it's called Saltville. But it's also been a salt deposit for millions of years, and that probably drew in a lot of these animals during the Ice Age as salt licks. And a lot of these animals became trapped in the valley. And so
you have to stop telling me this story because we are so far out of time. And I'm so excited.
But
Saltville excavations, I can go see an excavation at the Great Fossil Site. It's awesome. If you haven't been, you should definitely go. Thank you for joining us, Dr. Schubert. We've been speaking with Dr. Blaine Schubert about his work in the cave paleontology. Join us next time on Spotlight ETSU.
Thank you.